Hello guys, welcome to Statistics Bio 7. The channel fully focused on the biostatistics related data visualization and data analysis video post on the channel. If you like the channel video, click to the subscription button and support to me, join to our channel membership. Now we are the discussion topic for interpretation of point-Biserial correlation in R. How to analyze point-Biserial correlation in RStudio. That video already published in our channel. The continue part of the interpretation video. The analysis of point-Biserial correlation in RStudio. That video link mentioned to this video description box. Okay, let's go to the video. Interpretation of point-Biserial correlations. The point-Biserial correlation is a specialized form of Pearson correlation used to measure the relationship between a binary categorical variable, example for contamination levels low versus high, and a continuous variable, example for fish growth rate. In this study, we apply the point-Biserial correlation in R to assess the impact of heavy metal contamination of fish growth. Additionally, an independent t-test is conducted to determine whether the difference in growth rate between low and high contamination environment is statistically significant. Those analyses provide valuable insight into the potential ecological effects of pollution on aquatic life. The interpretation of point-Biserial correlation result. The table present for the statistics value and interpretations. The present for the statistics correlation coefficients, t-statistics, degrees of freedom, p-value, and 95% of confidence interval present in the table. So the interpretation of this table, the correlation coefficients. The obtained correlation coefficient is a RPP is equal to minus 0.709. This indicates a strong negative correlations, suggesting that an increase in contamination level is associated with a decrease in fish growth rate. The magnitude of RPB suggesting a highly meaningful relationship between those variables in an ecological context. The hypothesis test and p-value. The null hypothesis H0 states that there is no correlation between contamination level and fish growth. The alternative hypothesis HA states that a significant correlation exists. The obtained p-value is equal to 7.981 or p less than 0.0001, indicating that the correlation is statistically significant at the 0.05 significance level. Since the p less than 0.05, we reject the null hypothesis, confirming that the contamination level significantly affects the fish growth. The confidence interval. The 95% of confidence interval for the correlation coefficient is minus 0.825 and minus 0.537. This range does not include 0, reinforcing the statistic significance of the result. The negative value in the confidence interval further confirms the inverse relationship between contamination and fish growth. So the next one for the interpretation of independent t-test. The table present for the independent t-test, the statistics value and interpretations. So the statistics present for the content. The mean growth rate low contaminations, the mean growth rate high contaminations, t-statistics, degrees of freedom, p-value and 95% of confidence interval. So the mean growth rate comparisons. The mean growth rate for low contaminations group 4.88 centimeter per month. The mean growth rate for high contamination group 3.46 centimeter per month. This indicates that the fish is low contamination environmental growth, on average 1.2 centimeter per month more than those in high contamination environments. The hypothesis test and the p-value of the independent t-test table. The null hypothesis H0, there is no significant difference in fish growth rate between contamination level. The alternative hypothesis for the HA, there is a significant difference in fish growth rate between contamination levels. The hypothesis test and the p-value of independent t-test. The t-statistics is equal to 7.551. A large t-value suggests a strong difference in means. The p-value is equal to 1.059. P less than 0.001. Since the p-value is extremely small, we reject the null hypothesis, confirming that the contamination significantly reduces the fish growth. So the confidence intervals for the independent t-test, the 95% of confidence interval 1.039 and 1.794. This range does not include 0. The further confirming that the difference is statistically significant. We can be 95% of confidence that the true mean difference in the fish growth between two groups lie between 1.04 and 1.79 centimeter per month. So the another one interpretation for the box plot. The effect of heavy metal contamination on fish growth. The axis is present for the contamination level and y-axis is present for the fish growth rate. So the central tendency unsplit. The low contamination group blue exhibit a higher mean growth rate 5 centimeter per month compared to the high contamination group red, which has a median closer to 4 centimeter per month. The interquartile range IQR represented by the box show that the fish in the low contamination group have a wider distributions of growth rates, whereas fish is in the high contamination group have a lower and more compact distributions. The outlier and variability. The several outliers are observed in both groups for the low and high, particularly in the high contamination category, where some fish exhibited growth rate below 3 cm per month. The whisker indicate that the fish growth is more variable in the low contamination groups, with value extending the beyond 6 cm per month, while the high contamination group exhibited a more concentrated range. The statistical implications. A negative trend is even, suggesting that the increased contamination reduces the fish growth. The Point-Biserial Correlation analysis and t-test not shown in the plot would help determine if this observed difference is statistically significant. The next one, scatter plot interpretation for the fish growth waste contamination level. So the contamination level 0 low 1 high present the x-axis and the fish growth rate present is a y-axis. So the trend and correlations, the negative slope of the regressions, the lines suggesting an inverse the relationship between the contamination level and fish growth rate. Fish in the low contamination environments 0 generally exhibited higher growth rate and those in high contamination environmental 1. The shaded, the gray range represent the confidence interval indicating the uncertainty around the regression's estimate. The data distributions and variability, the data points are more concentrated around the two extreme the contamination level 0 and 1, the confirming the binary nature of the contamination variable. The spread of the data point suggesting some individual variations in growth rate within each contamination category. The fish growth in low contaminations variation more widely, while those in high contamination conditions show the low and more considered the growth rates. So the statistical implication for the scatter plot, the negative trend support the hypothesis that the heavy metal contaminations negatively affect the fish growth. The strength of the correlations, Point-Biserial correlation coefficients, solid be examined to the quantified the relationship. The further statistical test, example for the t-test and ANOVA, is required to determine if the observed trend is statistically significant. So the final part of the conclusion of the interpretation of Point-Biserial correlation in RStudio, the result of the Point-Biserial correlations and interpretation t-test reveal a strong negative relationship between the heavy metal contamination and fish growth. The correlation coefficients R is equal to minus 0.709, P less than 0.0001. They indicate a significant inverse the association, while the test confirms a statistically significant difference in mean growth rates between the contamination groups. Fish in low contamination environment exhibited significantly a higher growth rate 4.88 cm per month compared to those in high contamination environments 3.46 cm per month. This finding the highlight the determined effect of pollutions on aquatic ecosystem and emphasizes the need for effective environmental monitoring and pollution control strategies to protect the fish populations. If you want to the how to analyze the Point-Biserial correlation in RStudio, the full code published in the our Blacker page. This is for our Blacker page for the Point-Biserial correlation in our the full guide with the code. If you want this to analyze the code, below the page for our Blacker page, the download for the data file, click to the download the fish growth data set in Excel format, and full code access for the totally free for the Point-Biserial correlation in RStudio. So the important packages and the extra the additional for the box plot and the scatter plot diagram, also the code present in the Blacker page. If you any doubt on this video, leave me the comments in the comment box, and if you like this video, click to the subscription button and support to me, join to our channel membership. This Blacker page link also mentioned to the this video description box and the channel about page. Thank you for watching this video.